You know what you're doing, things fall apart. So 3, 4, solving. Usually when you learn new functions, you learn how they graph and how they behave and all that fun stuff. The end result is usually solving equations with them. How to undo them, get variables by themselves, and so forth and so on. Some of them we've already done. Some are solvable by the one-to-one property. I'll take a guess that you don't remember what the one-to-one property is for functions.
I remember going over.
Remember a little bit of it, right? If I write it, you'll remember it.
Yeah, I remember going over.
F of A is equal to F of B. What am I saying when I say F of A is equal to F of B? What are these things?
They're equal to the same.
I know, but what do they constitute on a piece of graph paper? What coordinates am I talking about? A and B as the x coordinate. What are the y coordinates?
F of A.
F of A and F of B. So basically I'm saying two y coordinates are equal to each other. And then the one-to-one property says if and only if the two x values are also equal to each other. And this is a vice versa type thing. If A is equal to B, if it's a one-to-one function, then F of A has to equal F of B. If F of A equals F of B, then A also has to equal B. So if I have something like 8 to the 2x minus 1 is equal to 16 to the x plus 4. Can you solve this? Well, if I'm going to use the one-to-one function, I have to make sure that the functions are exactly the same. Right now, the functions are different. This one's a base of 8, and this one is a base of 16. I need the bases to be exactly the same. So what base can I make both of those?
16.
I can't make both of them 16, because that means I'd have to multiply him by 2, and that's not really a base. Bases are like 8 times 8 would be 64. Or 16 times 16, 256. So what number can I create that both of them have in common?
32.
2, right? So I can write 8 as 2 cubed, but it's being raised to the 2x minus 1. And 16 is 2 to the 4th, and it's still being raised to the x plus 4. So now you have the same base. All right, go one more step. Power to a power, what do?
You add them.
I'm going to beat you up.
Multiply them.
You multiply, power to a power, multiply. Everything else is found by that. So this becomes 2 to the
6x minus 3.
6x minus 3. The other side becomes 2 to the
4x plus 16.
4x plus 16. Now because the bases are exactly the same, that's like your f of A is equal to f of B, then this is A, this is A, and this is B. What must be true about them?
They equal the same.
They have to equal, right? Because if the y values are equal, therefore the domains are also equal. So it's not algebra. You're not canceling the 2's. A lot of people think, oh, you're canceling the 2's out, but that's not what's happening. Basically, you're just saying if the y values are equal, their domains are equal also. So this just implies that 6x minus 3 is equal to 4x plus 16. And it becomes a nice, easy, linear equation. We'll say that it's 2x is equal to 19, x is equal to 19 halves. Simple. That's it. So, do they get any harder than that? Hey! He was half dead. I could always throw your favorite things into it. 1/8 raised to the 4x plus 1 is equal to 4 raised to the x minus 3. So if I'm going to use the one-to-one property, what do I have to do to the bases?
Give them the same.
Same. What's the same base?
What
does an 8th and a 4 have in common?
2.
2. So how do I write 1/8 as 2 raised to a power?
2 raised to the 3rd.
Good guess. Except 2 raised to the 3rd is 8, not 1/8.
He's got it.
What did you say?
Negative 2, 3.
So remember, reciprocals, negative powers, reciprocals. So this becomes 2 to the negative 3 raised to the 4x plus 1 is equal to, and then 4 of course is 2 squared raised to the x minus 3. Wake up, wake up, wake up. Power to a power, what do you do? Multiply. So this becomes 2 raised to the,
12x.
careful,
Is negative.
negative 12x
Minus 3.
minus 3. The other side becomes 2 to the 2x minus 6. Now once you get the bases exactly the same, the domain part of it also has to be equal. So this implies that negative 12x minus 3 has to equal 2x minus 6. Nice, easy thing to solve. So move that over and you get 14x. Move the negative 6 over and you get 3. And then you get x is equal to a very friendly answer, 3/14. Now you can check your work. You can take your answer, plug it back in, and show that the two sides actually equal each other, but 3/14, it's not fun to play with, but you could do it. You could do it. There is a possibility, though this book doesn't do a lot of it, that you could have something like log of x squared. Let's do plus 5x is equal to log of 6. Something like that. This also falls under the one-to-one property. Logarithms are one-to-one. And as long as it's a log on one side and the same log on the other side, what can I say about this?
Yeah, equal the
The insides equal the same. So all you have to do is pop out the inside and set them equal to each other. So this must equal that. So x squared plus 5x is equal to 6. How do you solve that equation?
same. Negative 6 over.
Move the 6 over, you get x squared plus 5x minus 6 is equal to 0. Then what?
Yeah, did.
Stare at it for a while.
You can't solve
Yeah, you can.
that. Can you really?
Oh my gosh, yes. And
Plus and minus
did you forget how to factor?
1. X plus minus 1, 5,
1 and
6.
6. Factors of 6 that subtract up to 5 are 1 and 6. So this is a quick factor. 1, 6. What kind of 1? What kind of 6?
Negative.
Negative 1 and positive 6. And then just put x's in front. So you get x plus 6, x minus 1. Did y'all forget how to factor? Guess what? It's coming back in a strong way soon. Alright, so when you solve this, you set each factor equal to 0. So you're going to get x equals negative 6 and x equals positive 1. Are both of them my answers? Why?
Because it can't be negative 6.
Why not?
Because there's a 6 there, and it can't equal 0.
Things can equal 0.
Oh, it's
Well, log of 0 would be kind of bad, though. But if I take negative, well, let's take 1. If I take 1 and plug it back in, you're going to get 1 plus 5, which is 6, and that equals the other side. If I take negative 6, negative 6 squared is
36.
36. 5 times negative 6 is negative 30. 36 minus 30 is 6. It works out perfectly fine. So actually, both of these are the answer. Try to find one that isn't. How about this? If I have log of, let me think, x squared minus 5 is equal to log of 4x. I think this will work. Let's see what happens. When I make these up on the top of my head, it usually doesn't work out real well. So again, the insides are going to equal each other because you have a log equal to a log. That's really important. It's a single log on the left, a single log on the right. There's nothing else lying around. Then you can pop out the inside and set them equal to each other. All right, how do you solve that?
Yeah, 4x.
So you get x squared minus 4x minus 5 is equal to 0. Does it factor?
Yes.
How's it factor?
Negative 5 positive 1.
Negative 5, positive 1, x and x. And you get x is equal to negative 1 and x is equal to positive 5. Are both of them the answers?
No.
Why?
Negative 1 and... Oh, wait. Which one? How did you get
I'm asking. Are both of them the answers?
You'll have negative 4, won't you? That won't be.
This
You
one?
use the
Yeah.
one, yeah.
Yeah, I'll get a negative 4. What's wrong with that? What's wrong with negative 4? If I take this and plug it back in to either side, I'll get log of negative 4, log of negative 4.
It works.
And it works?
Yeah.
Really?
Yeah, you can have negative.
Logs can't take negatives. Remember, the graph of log is crawl up the negative y-axis and shoot that way. You don't spit out answers if x is negative. It's not part of the domain. So this one is definitely not an answer because it doesn't fit the domain.
Next one.
Does 5 work? Well, let's see. 5 squared is 25. 25 minus 5 is 20. 4 times 5 is 20. They're both positive, so this one works perfectly fine. So where exponential functions, it doesn't matter what the answer spits out because exponential's domains are negative infinity to positive infinity. Logarithms, you always have to be careful. The log of a number has to be a log of something that is strictly positive. Not zero, not negative, strictly positive. All right. Those are the simple equations. Let's make it harder. And I think we've already done this once, but let's do it again.
So I can see those are the videos that you're doing right now.
Yeah, I posted the first 3 already. I just got to create a link for it so you can get to it quickly. I already put them in a playlist. I just haven't done the linking part yet. More difficult. Now, which ones do you think are going to be more difficult? The logarithmic equations or exponential function equations? You think it's logs, right? Because logs seem more difficult. In reality, though, it's the other one, which is kind of scary if you think about it. Exponential functions are usually the weird ones. These aren't too bad either. These are the most common of the exponential types. For instance, if you have 5 raised to the 2x minus 1 is equal to 50. Here's a case where you cannot create the same base on both sides of the equation. If I could write this as 5 raised to a power on the left and 5 raised to a power on the right, my life would be set, because then I just have to look at the exponents. But in this case, I can't do that. So I'm going to have to pull tricks out of the hat to finish it off. So what I'm trying to solve for is x, and the problem for solving for x is it's in the exponential location. So what's the only thing that we can solve for? Well, we can't solve for exponents. We can generally solve for regular old algebra, polynomial, x in the bottom. So what will bring my x down from the exponent? There's a function that'll do that.
Do we know it?
Yes, because it has properties.
Square.
Properties. Hint, hint, hint. We did it yesterday.
You divide it with both sides.
Properties.
Please excuse me, dear.
Not those properties. The properties we did yesterday. The log of m times n is equal to the log of m plus the log of n. That doesn't apply here. The log of m divided by n is the log of n minus the log of n. That doesn't apply here.
You're talking about p?
The p one. Where does p go when you log?
I don't know.
As a regular number.
Yeah.
That's what I want. I want x to become a regular number. Right now it's not a regular number, it's an exponent. So the trick I'm going to use is I'm going to log both sides. I choose ln. Why?
How many of the difference between?
Well, between ln and log?
Yeah.
What's the base of ln?
E.
E. What's the base of log?
10.
10. Why do I choose ln? Seriously, it's an easy answer. 2 letters. How many letters are in log? 3. I'm lazy.
Wait, what's the difference between that?
Not much, other than their bases. ln has a base of e, log has a base of 10. But when I do logging both sides, I choose ln because I only have to write 2 letters, because I'm lazy. But you can write log or log base 2 if you really wanted to, but that's not worth it. So I'm just going to ln both sides. If you wanted to, you could ln base 5 both sides. That will work. Or change this into a logarithm. That'll do the same thing. But then you have to use the change of base formula at the end, if that's just an extra step. So if you ln both sides, the insides don't change. This will be 5 raised to the 2x minus 1, and the side will have 50. Alright, what happens?
You get 2x minus 1 by itself.
So you drop 2x minus 1 out front. You have ln of
1.
just the 2x minus 1 dropped out front, this part right here. He goes out front, what's left behind? ln of
5.
5. That didn't move. Equals ln of 50. Okay, now what? Trying to solve for x. What do you need to do?
Simplify.
It's just a linear equation. So how do you solve for it?
Plus and minus.
We just have to say plus or minus. That's for quadratic formulas and stuff.
You
How do I solve for x?
get it by itself.
How?
You divide by 5.
Just 5?
Set it equal to 0.
Just 5.
With ln
The ln too. You can't separate the ln and the 5. They're locked together like square root of 5. So you divide both sides by ln of 5. And you get 2x minus 1. Don't need the parentheses anymore because the ln of 5 is gone. And on the other side you have ln of 50 divided by ln of 5. When you see something like this, just think it's a number. That's all it is. It's some funky number when you type it in the calculator. If you type it in the calculator, you have to give it at least 4 decimals if you're going to approximate. But I highly suggest you just leave it like that. Alright, how do I solve for x?
Subtract 1. Same thing.
No, it is not.
Just drop it.
You're adding 1 to the other side. So you get 2x equals plus 1 or 1 plus. It doesn't matter. I usually just do 1 plus. ln of 50 divided by ln of 5. Alright? And then what? Divide by 2. Now it comes in handy if you have a calculator. You don't have one yet?
I don't agree.
Oh, it's math class without calculator. This stuff gets very complex from here on out. ln of 50, you need a calculator. Divided by ln of 5, the whole thing, messily, divided by 2. Alright, I'll even type it in my calculator.
Did mine on my phone last night.
Hmm?
I typed that in on my phone last night. Not maybe not that, but something else.
Something friendly. Ln of 50 divided by ln of 5. The reason I want you to have your calculators is so you can type this in and make sure you're typing it in right, because there's so many mistakes you can make trying to type that into a calculator. This comes out approximately, when you do, this is what's called the exact answer. I mean, that's the exact answer. When you type it into a calculator and you even write down every decimal that you see on a calculator screen, it's still approximate. It's not exactly equal to. Generally a irrational number. The decimal goes on forever and ever. Never repeated. So, can you check this thing? You can try. You can take this answer, go back to the beginning of the equation, plug it in for x, and see if it actually if you raise it to 5 to that power, if it comes exactly 50, do you think it'll come out to be exactly 50?
Yeah.
But we were putting in an approximate answer.
I'm sure if you hit multiply on that, you could do it.
What do you mean?
It's like times 2.
Alright, so times 2 minus 1, get that answer. Take it and go 5 raised to that answer. Comes out exactly 50. Weird. But it's not true, because it's not exactly the number. So calculators are kind of liars. They round eventually. It was probably 49.999999998, but the calculator doesn't go out to that 8, so it just rounds it to a perfect 50. Isn't that weird? Everybody thinks calculators are perfect. They're not. If I did this in my computer, it would be 49.9999999, a bunch of 9s and then an 8 someplace. If you just plugged this number in, it wouldn't come out exactly. It would be a little bit off. So don't let that throw you. That's a decent answer. But you could kind of check it. It's not going to be perfect. All right, how about this? How long will it take an investment of $1,000 to triple in value at an APR, annual percentage rate, of 8% compounded monthly? And the formula is this. Tell me what to plug in.
1,000.
Where's it go?
8.
No. A is how much is in the account after a period of time has already passed.
G.
P. So 1,000 goes into P. What goes into A?
8.
A is how much money is in this account after a period of time.
Total investment.
Hmm?
Total investment, right?
Yeah, total investment. How much do I end up with after a period of time?
That would be A, right?
Yeah, that's what A is. So what is it?
Monthly.
No, that's N.
It's,
Okay, read the problem again. How long will it take an investment of $1,000, which is in P, to triple?
3.
3 times as much. So what goes into A? 3. I start with 1,000. What am I going to end up with? 3,000. 3,000, 3 times as much. So 3,000 goes in for A. I want to know when my $1,000 turns into $3,000, which is triple of how much I invested to begin with. Then it goes 1 plus, what's R?
8%.
8%, so that'd be 0.08.
Yeah.
What's N? That's that compounding thing. If you compound monthly, this is N. What's it mean to be compounded monthly? What would N equal?
30, 31.
How many times a year?
12.
12. And then you get up here, 12t. Guess what we're solving for?
T.
T. How do I solve for t?
You use that form property.
Not yet. Can't. Something's in the way. The difference between these two is this is 5 raised to a power is equal to a number. I don't have something raised to a power equal to a single number. I have a bunch of things in the way. Well, especially that 1,000. So guess what I have to do to that 1,000?
Divided.
Divide it. So you divide both sides by 1,000. And you get 3. Triple 3. Guess what would happen if it was double? This number would be 2. If it was half,
0.5.
it would be 0.5 and so forth and so on. So it gives you a little hint. On this side, what's 1 plus 0.08 divided by 12? Should I leave it written that way? Or can I combine it?
You should leave it.
It's better to combine it. Make it a single number, because then you have a single number raised to a power. So 1 plus 0.08 divided by 12. 1.00666666666666. Well, I'm not going to write all of them. So 1.00 and then a bunch of sixes. I'll write that much. Raised to the 12t. 6 repeating. All right, still trying to solve for t. What should I do?
Move it in front.
I can't yet. I can't just go, oh, I'm going to take that power and put it in front, because then I could just take x squared and write it as 2x. Does that make sense? So squaring a number is the same thing as 2 times a number.
L.
ln in front. So I'm going to ln this side, and I'm going to ln that side. You and skipping steps. That'll get you in trouble. 3, 1.00667 raised to the 12t. Okay. Now what? Move it in front. So you get ln of 3 is equal to the power in front, 12t, times ln of 1.00667. Okay. Now what?
You divide by 1.00.
1.0667 doesn't exist. It's not a number. When you look at this, what's the number?
Irrational.
It's irrational. It's the square root of 2. It's not 2. You can't look at 2 as an individual number because it's the square root of 2. You can't look at 1.00667 as an individual number because it has a ln in front. So the number that you're looking at is all of that. I know what you mean, but I got to get that language out there because otherwise you are going to divide both sides by 1.00667 because it looks good. But then you leave behind an ln and that makes no sense. What else do you want to divide by while we're here?
12.
The 12, yeah, because you want to get t by itself. So I'm going to divide this entire side by 12 ln of 1.00667. And if I divide both sides by it, it'll give me my answer. And you get t by itself. Well, it's going to be approximate. I'm not going to be perfect with it. Alright, so typing this in. When I type it into my calculator, how do you think I should type it? I'll type in ln of 3 first. So ln 3 and parentheses. Divided by.
12.
And you'll get the answer wrong. Remember what long fraction bars represent? Oh, really? If you were going to type this into a calculator, how would you do it? Would you type in 2 divided by 4 plus 3?
No.
Would it give you the right answer?
I would not.
I don't think so either, because 2 divided by 4 is a half. A half plus 3 is 3 1/2. But it really should be 2/7.
You should put 12 in parentheses.
Parentheses. Long fraction bars are an old notation for parentheses. You have to contain it, otherwise your calculator is going to spit out gibberish. So let's see here. Parentheses, 12 times ln of 1.00667. For a grand total of 13.77. So it would take 13.77 years for your money to turn from $1,000 into $3,000 at a constant interest rate of 8%. Yeah, but that $2,000 you did nothing to do. You just let it sit there. It's not bad if you think about it. It's not the easiest way to save money, but it's a way. So that's probably one of the harder ways of solving.
So what is the percentage per month?
8% per month? Well, it's not 8% per month. It's 8% per year.
Yeah.
So if you divide it by 12, that's how much it is per month, and it's not that much. Of course, it's better than bank accounts nowadays. 1%. You know how long it would take you to triple your money at 1%? Oh, 100 years.
8.
Hmm?
It'd be like that times 8.
No, it gets much more complex because it's in that ln thing. Remember, ln's drop numbers values. So, you want me to figure it out? 1%? It would be 1 plus 0.01 divided by 12.
87.
109 years.
Oh, that sucks.
That's why saving right now is pointless, because if you put money into a savings account, you earn 1%. Inflation is 3%, so you're losing 2% of your money every year by just saving it. So there's no point in keeping your money. That's why the interest rates are low and they want you to spend money. Now when the interest rates go up again, that's when you want to save money, because then you're outstripping inflation and you're making money on money. Does that kind of make sense? Money is weird. You have to be really careful with it.
Inflation went up.
Inflation's always going up. It's generally about 3% per year, but because of the last recession, it actually bottomed out to be about 0. So 1% is all right, but it's nothing big, one way or the other. When it comes back to 5%, that's when you start saving again, or you find other investments that give you more money. So these logarithms actually have, straight meaning. If you're saving up for retirement, you'd ask a question: how much money? I need $1 million in 30 years, or I need $1 million. How long is it going to take me to get there? Generally 36 years. If you save $1,000 a month, guess how much you're going to need when you retire? I need $1 million. Guess how much you're going to need? Probably 2.
So I'm gonna be a millionaire.
Yeah, good luck.
I already have a business plan.
I know. Let me get rid of this. Alright, so that's one way of solving. lning both sides, bring the power down. Probably the hardest problem, and I love putting it on a test.
The hardest problem you're about to do.
Uh-huh. You want me to pause and do a different one? I can do a different one.
Oh, that's too bad for me.
Uh,
Go ahead. I'll be right back.
we'll do the easy exponentials first. The easy type. Kind of similar to the last two. For example, if you have 15 is equal to 3e to the 2x minus 1. One of these days you'll take notes.
Yeah.
Yeah. You worry me. How would you start solving for this?
Set equal to ln.
Nope.
Divide by 3.
Divide by 3. Gotta get the exponential function totally by itself. Alright, so this gives you 5 is equal to e to the 2x minus 1.
You should put an ln on there.
Put an ln in. Now, why would I choose ln over log in this case? Not just because it's 2 letters.
Because it's e.
Because it's e. When you ln and e, they're just going to go poof because they're inverse functions. So I'm going to ln both sides. And that's another reason I like using ln, just in case. This side is 5. This side is e to the 2x minus 1. When ln and e run into each other, they go poof, they disappear. The left-hand side stays ln of 5. The right-hand side, the ln and e go poof, and all you're left with is
2x minus 1.
2x minus 1. Just drops that exponent right down without even having to go out front. If you did put it in front, ln of e is equal to 1. Therefore, you just get this anyways. Alright, and then just solve for x.
1 on the other side.
Move 1 over, you get 2x is equal to 1 plus ln of 5.
And divide by 2.
And divide by 2. So you get 1 plus ln of 5 all divided by 2. The exact answer. If you type this in the calculator 2 different ways. Type in the top, hit equals, then divide by 2. That's the safest way. If you do it otherwise, you have to put a parentheses in the front and a parentheses in the back because there's 2 pieces in the top. Kind of like there was 2 pieces in the bottom before. You had to be careful with it. And it'll give you a nice answer. Not bad, right? Easy. So if you see an e function, you think directly ln. Think directly ln. All right, so here's the hard one. If I have stars on this thing, difficulty level, really hard. Lots of people can't do this one, but I still put it on the test because I'm a jerk. Okay, and it works this way. 5 raised to the 2x minus 1 is equal to 3 raised to the x plus 1. You're thinking to yourself, oh, we did this earlier. It looks really similar, right, to the first ones I was doing. The problem with it is the bases are not ever going to be the same. Neither of them. So what's the only option available to me?
Leave them like that and call it a day.
No. We never call it a day. I don't leave things blank. What have we been doing so far for these problems? Lning both sides. That would solve our problem because it brings both of the exponents down to be regular old variables. So I'm going to ln both sides and see what happens. It's not a very pretty sight, but I better write in blue, otherwise it doesn't erase. So this is 5 to the 2x minus 1. Bless you. This is 3 to the x plus 1. And we put the powers up front. So drop the 2x minus 1. And it's times ln of 5. Drop the x plus 1. Remember to keep them in parentheses. They're grouped. You know, x plus 1 is a single number. And it'll be times ln of 3. At this point, you have a choice. You can work with it the way it looks. It gets very messy, and it raises the possibility of you making silly mistakes like dividing by 3 or dividing by 5, even though there's no 3 up here and no 5 up here. So there's a little trick you can play. I like playing tricks, and I use tricks all the time. Since algebra is the replacement of numbers with letters, these two things are the ugly things. And there's too many things you have to write. You have to write the ln, the parentheses of 5, the parentheses. You know, that's a lot of writing. So what I like doing is replacing ln of 5 with just the letter A, capital A, and replacing ln of 3 with the capital letter B, and just rewriting the whole thing in terms of A and B. So this becomes 2x minus 1 times A is equal to x plus 1 times B. And it makes it look a little bit nicer, I guess. How would you solve for x in the red equation? What would you do first? Divide by? Multiply what? Oh, come on. You see a linear equation like this, what do you want to get rid of? No, you can't get rid of letters in equations. If I got rid of the A and the B, just ignore them, and put 3 and 5 in there, instead of ln of 3 and ln of 5, what would you do with the 3 and the 5?
Multiply.
What do you mean by multiply?
Until
Distribute, right? You would distribute them through and get rid of the parentheses. To solve a linear equation, you have to get rid of the parentheses to loosen things up so you can move them left and right side of the equation. So distribute. A times that, B times this, B times that. So this becomes 2ax minus A is equal to bx plus b. Okay, now what? They're all loose, the pieces. You can move the puzzle pieces around the equation. What puzzle pieces do you want to move?
the A.
Just these A's? Or that
A.
A? Your focus should be on something else. You're solving for what?
Yes.
Now you have an x on the left-hand side and an x on the right-hand side. Where do you want them?
Together.
On the same side, right? So my first thing would be move bx over. Now if I move bx over, I'm definitely going to move the a. If I move the 2ax, then I'd move the b. That's just how I roll. I move the x's first and the numbers the second. So if I move the a and the bx, I'm going to get 2ax, subtract the bx across, add the a across, and you get that. focus should be x, nothing else, just the x.
Divide by A and B.
If I divide by a and b, you're going to get a horrible mess. Like, this would become 2x over b, this would become x over a, this would become 1 over b, 1 over a. Lots of ugly fractions, not worth it. Your focus should not be on the a, the 2, it should only be on the x. What am I trying to solve for? Well, x, but the problem is it's in 2 different locations. So how do I create just one of them?
Would you factor?
Pull it out.
Say it again?
Would you factor out?
Factor, pull it out, right? So you kick out x, what's left behind?
2A minus B.
And it's equal to a plus b. This is the distributive property, backwards. And it's basically how you add 2x plus 3x together. You say, oh look, the x's are exactly the same, therefore they're like terms. So you ignore it. Then you take the 2 and the 3 and you add them together and you get your 5x. That's shortcut language, but that's where it works nicely in this type situation. So you're going to get x is equal to a plus b over 2a minus b after you divide both sides by the number that's sitting next to x. Whew, that's great, except for one problem. We want a value out of this a specific number, or at least an approximation. Go back and put in your ln of 5 and your ln of 3. So this, when you substitute back in, is ln of 5, that's a, plus ln of 3, that's b, divided by 2 times ln of 5, a, minus ln of 3, b. Now, your choice. You can type that all into the calculator. It's not very friendly. Parentheses ln of 5 plus ln of 3, parentheses divided by parentheses 2 ln of 5 minus ln of 3, parentheses. Lots of parentheses. So you have that choice. You can just type it in. It takes a while. Or you can use the property of logarithms. What's ln of 5 plus ln of 3? What does that mean? The plus. Between 2 logarithms, what does it mean when you have a plus? Multiplication. So you can rewrite this as ln of 15 in the top. I'm just trying to go through the properties again. Why not? What does a 2 in front of the ln of 5 mean? Squared. So this is really 25. What does a minus mean? Fraction, basically. So this becomes ln 25 thirds. That's much easier to type into a calculator. So either choice, you could leave it in an expanded form or you can contract. I want you to get used to contracting because later on it's going to come in kind of handy. Now, is it a very difficult problem? Yeah, most people have problems with it because they don't know what to do with ln of 5 and ln of 3. Therefore, I put in the a and the b. But solving it is really not that bad. It's actually kind of simple. All you need to do is, well, practice. Practice a couple of times. Alright, what other types of equations? Let's look at the book and see if I'm forgetting any. Those are property. Oh, I want to go back to those anyways. We'll go back to do that later. Oh, we have to do those. Alright, we're done with exponential except for that type. Trying to see if I can fit it in here. Let's put it right here. Box. How about this one? It's an exponential equation, it's just set up weird looking. What does it look like?
Looks like you have an L
No, this one, not till the very end. When you see things like 1, 2, 3 terms and it's equal to 0, what should your brain be thinking? Factoring. Now, you can directly factor this, but some people have a hard time looking at this and seeing what it really is. So there's another method, it's called U substitution, and you take the middle variable, in this case it's a middle function, e to the x, and you say, well, let u equal e to the x. And the trick is this. If it's going to work, you square both of those sides of the u equals ex. If you square it, what does it become? Well, the left-hand side is easy. It's u squared. What's the right-hand side become? When you take e to the x and square it, what do you get?
E to the 2x.
E to the 2x, because a power to a power u multiply. So u squared becomes e to the 2x. And if this method is going to work, that has to be the first thing, which is e to the 2x. So where I see e to the 2x, I'm going to replace it with u squared. Wherever I see e to the x, I'm going to replace it with u. So this becomes u squared minus 2u minus 3 is equal to 0. Okay, what can you do with u squared minus 2u minus 3 equals 0?
You can subtract it.
Nah, stop that.
Plus or minus.
Stop plus or minus. I'm going to throw things at you. Factors of 3 that subtract up to 2. You can factor it.
Yeah.
So, language. Factor. Alright, so this becomes u, what kind of 3 and 1? Because there's no other options. Negative 3 and positive 1. So you're going to get u is equal to positive 3 and u is equal to negative 1 after you set them both equal to 0. You understand why you set them both equal to 0, right?
Mm.
Why?
So we can move it to the other side.
Nah, it has nothing to do with that.
So you know what you can't have.
How do I know that one of these is 0?
What do you mean?
How do I know that u minus 3 is 0 or u plus 1 is equal to 0?
You said it equal to 0.
Nah, there's a reason why I set it equal to 0. How do I... The only reason I set them equal to 0 is because I know one of them is. How do I know one of them is?
Counts just do.
If you take the product of two numbers and their answer is 0, what's the only possibility to get an answer of 0 under multiplication?
Multiply by 0.
Multiply by 0. So that forces one of these to be 0 because there's no other way to get an answer of 0. That's why you do it. Never knew that? You just kind of set it equal to 0.
Yeah.
Don't. It's the reason is because one of them has to be 0 because a product can't equal 0 unless one of them is 0. Because you get 1 times 2 is 2, and any other product is going to give you an answer other than 0. All right, are both of them our answers?
No.
Are either of them our answers?
Maybe.
No. Because I solved for u, what I'm looking for is x. So what I have to do is go back to my substitution line, which is this one here, and say, well, if u is equal to e to the x, then this u is, go back to my red marker, that u really represents e to the x is equal to 3, and this other u is e to the x is equal to negative 1. Does that make sense? So basically, I'm just going back to my original problem. How do I solve e to the x equals 3 for x?
You ln.
You can ln both sides, or you can write it as a logarithm, and either one comes up with the exact same answer. This would turn into ln of 3 is equal to x if you just switch it as a logarithm. If you ln both sides, the x comes down out front, and you get x equals ln of 3. Either one works out. What about him?
You can't do it.
Why can't I do it?
There you go.
E to the x is never negative. Or if you log both sides, you would get x is equal to ln of negative 1. And you can't take ln of a negative number. So this one gives you nothing. It's what's called an erroneous solution. So the only answer here is x equals ln of 3. Kind of cool. I always like those things. Factor and solve. Now, you don't have to use the u substitution method. If you look at this correctly, it is 3 terms. It's squared and just single x. Factors of 3 that subtract up to 2, you could write it as e to the x minus 3 and e to the x plus 1. But that takes some skill to recognize that. That's why I like the u substitution, just in case. Just in case. There you go, this. All right. Other than exponential equations, there are logarithmic ones. For example, log base 2 of 3x minus 7 is equal to 4. That's what's considered a logarithmic equation. And there's actually two ways of solving it, but where we log both sides to bring powers down, it's really difficult to use the inverse function properly here. So it's generally easier just to write it as an exponential function. So convert to exponential. Because exponential functions are the ones we learned most about solving, it would be easier just to see this as an exponential function. So what does it look like as an exponential function?
It's not exponential variable.
How do you change a logarithm into an exponential? What's the first thing you look for?
Base.
The base. What's the base?
2.
2. What's the power?
3x minus 7.
4.
Oh,
Remember, logarithms say, what power do I have to raise 2 to get 3x minus 7?
Oh,
And the power is what the logarithm is equal to. So 4, and it's equal to 3x minus 7. Can you solve for x now?
Yeah.
Add 7 across, you get 3x is equal to 2 to the 4th plus 7, and divide by 3. So you get x equals 2 to the 4th, 16. 16 plus 7, 23 thirds. Nice little answer. So logarithmic equations aren't too bad, except I don't give them to you that easy. I usually do weird things like ln of x plus 5 is equal to 2. Make you think. So how do I solve that one?
You put the x plus 5 in front of the ln.
E. Because the first thing you have to recognize is base. Power? 2. What's it equal to? X plus 5. And to finish it off, you're going to get x is equal to e squared minus 5. You can type it in a calculator and get an answer.
Just put an e there.
Yeah, but the base of ln is e. Base of log is 10. Those are two things you have to know. Alright, what about that?
So, that's the answer?
What, e squared minus 5? E squared is about 9, 9 minus 5 is about 4. I mean, you could type it in a calculator and get an approximation, but it looks prettier as e squared minus 5. Because that's the exact answer. As long as the answer is not written horribly, I'd rather you leave it in exact form. You start getting things like ln of 2 plus ln of 5 divided by ln of 17 minus ln of... I'd rather you write that as a decimal. But if it's just e squared minus 5, just leave it alone. Alright, first step. Base is 10. So 10. Power?
3.
3. What's it equal to?
4x plus 7.
And it makes life easy to solve. What's 10 cubed?
1,000.
1,000. So this is 1,000 is equal to 4x plus 7. Subtract 7. And divide by 4. Once you get past that first step, it's really easy. Nice, simple, linear equation. Alright. Do those get harder? Well, not much harder. Let's steal a couple from the book. Oh, the red doesn't erase either. Oh well. Down to one color. That's a good one. No, that's actually kind of boring. How about this one? Can I just write 4 raised to the first power equals what?
X plus 2 minus X plus 4.
That doesn't seem right, does it? Yeah.
I
So the first thing you have to do is get it into one of the first types forms. If you look at each one of them, it's log of something equals a number. A single log of something equals a number. This is 2 logs equals a number. So is there any way of writing it as a single log equal to a number?
What's X plus 2.
Back to the properties. If I have a log minus another log, what does that really mean? It's division. So write it as division. This becomes log base 4 of
X plus 2
x plus 2 over x minus 1 is equal to 1. So you combine them and contract these logarithms. Alright, now you can do it. I have a log of something is equal to a number. So what do I start with?
log of 4.
4. You don't start with log of 4, you just start with 4 raised to what power? First power, which is equal to? Well, I know that's equal to 4, but what's it equal to?
X plus 2 over X minus 1.
X plus 2 over x minus 1. Alright, how do I solve that equation?
You take 4 to the first number.
Huh? Well, 4 to the first power is 4. That's boring.
Multiply.
Multiply both sides by
X minus 1.
x minus 1. So this becomes 4 times x minus 1 equal to x plus 2. This is 4x minus 4 is equal to x plus 2. I'm assuming you know how to solve linear equations. That's usually a bad assumption, but I'm going to keep on assuming it. Move the x, you get 3x. Move the 4, you get 6. And you finally get x is equal to 2. With logarithms, you have to be careful. Remember, you can't take log of a negative number. So if I take this answer and plug it back in, does it cause log of a negative number?
Okay.
Does it?
Um,
No. What's 2 plus 2?
4.
That's positive. What's 2 minus 1? 1. That's positive. So that's perfectly fine.
You got a negative.
If you take it and plug it back in, it becomes log of a negative number. It can't be an answer. Because logs can't do negative numbers. They don't like them. They don't know what to do with them. One more.
Is this stuff going to be chapter 4 too?
Hmm?
Or are we doing this stuff the rest of the class? Or was
Oh, through the whole class?
oh, so what, after this chapter we're done with it?
And logarithms and exponentials. So they come back to bite you. But inside of this is still factoring, factoring, factoring. It just keeps coming. So if you don't remember how to factor, tell me. I'll show you where to go. What's worse? Ooh, that one's kind of cool. Log base 2 of x minus 3 plus log base 2 of x minus log base 2 of x plus 2 is equal to 2. Did I write it right? Yes. Alright. How do I solve?
So it'd be 2 squared
Nope.
equal, so what would it be?
Oh, you're skipping steps, aren't you? Don't do that. What should I do first?
Log base 2.
Combine all my logs. Write it as a single log base 2 of. Now tell me of what?
X minus 3.
X minus 3.
And then multiply by x
Multiply by x.
over x plus 2.
X plus 2. And this whole thing is equal to 2. Now you can say, what's the base?
2
It's
squared
2 squared equals.
x minus 3 over x.
And I'm going to write it as x squared minus 3x over x plus 2. Multiply both sides by, and this of course is 4, so you're going to get 4x plus 8 is equal to x squared minus 3x.
You move the x's on one side. And you move everything on one side.
Move everything one side. Keep the x squared positive. So this becomes 0 is equal to x squared minus 7x minus 8. I think. Yeah. Now what?
It's x plus minus 8x plus
With a yawn. And this is equal to 0, therefore x has to equal
8.
8. Or x equals negative 1. One or the other, or both. Is it both?
No,
Which one it can't be?
it won't.
Why can't it be negative 1?
Because it's a negative.
I don't care if it's a negative on the answer. Why can't it be negative 1?
Logs don't like negatives.
Am I taking log of negative 1 anywhere?
No.
Yeah, no, right here.
Yeah,
Log base 2 of negative 1.
you can't do that.
You have to go back and look, though, because this could have been log base 2 of negative x, and negative answers would be perfectly fine. The positive one would fail. So it's not just because the answer is negative, it's because when you plug it in, it generates a negative answer. Especially in that one, too. Negative 1 minus 3 is negative 4. If you came up with x equals 2 down here, let's say, for instance, you got x equals 2 as an answer.
0.
Would it work?
No.
Heck no, because if you put it here, it'd be 2 minus 3, which is negative 1. So just because an answer is positive doesn't mean it works.
What if they give you a 0? It would be wrong.
0 is wrong, too. You can't have ln of 0.
Okay.
That wasn't part of our problem anyways, but this is an erroneous solution. 8 should be the only one that works, but I like checking it. Keeps it positive, keeps it positive, keeps it positive.
It can't be 1 either, can it?
1's fine. ln of 1 is just 0.
It is, okay.
Yeah. Log of 1, ln of 1, log base 2.
So was that like